Here are our notes for day 2 of our statistics unit using dot plots, stem plots, and the shapes of graphs. Started off by doing a little survey and taking some data. How many states have you visited? This is a sample set of data. The next question was, how old is one of your grandparents? Again, a sample set of data that's already been taken down. We're going to use this a little bit later on when we do stem plots and dot plots. Next, we're going to talk about the shapes of graphs. The shapes of graphs mainly are looking at things like a bar graph or a dot plot or a stem plot. You can really use any of those to determine the shape. Symmetric is just what it says. It looks like it's the same on both sides, usually going up in the middle and coming back down. Skewed right has a majority of the data on the left side of the graph and then it goes to the right. This is called a tail. Whichever way the tail is facing, that's how it's skewed. So when the tail is on the right, it's skewed right. When the tail is on the left, it's skewed left. Bimodal means that there's going to be two parts of the data that are approximately the same height. They don't have to be exactly the same height. So whenever you have two parts that are higher than the rest, that is bimodal. Uniform means that they're all pretty much the same set of data. Kind of ignore this down here because this really shouldn't be here. It's really just if they're all pretty much the same. Now they're not going to be exactly the same. They're just going to be approximately the same when you look at the graph. So let's look at a couple of examples of that and see what we mean. If I were to look at this first graph here, this is one I would say is bimodal. As you start here, you go up and then come back down and then go up again and come back down. So there's two areas here that are basically higher than the rest. So that would be bimodal. This graph here, there's a little data here, but the majority of the data is off to the right. Because the tail is on the left, we'll say that that is skewed left. If we look at a couple more graphs, number 6 here, this graph is symmetric. Now again, it's not exactly symmetric, but it's pretty close to that, so that's what we mean when we say symmetric. And this graph here, again, would probably be considered skewed left, because the tail is on the left-hand side. The next thing we're going to look at is something we're going to call SOX. SOX stands for shape, outlier, center, and spread. For shape, that's what we were just talking about. Is it symmetric, skewed right, skewed left, bimodal, or uniform? An outlier, look for a significant gap in one piece of data versus the rest of the data that was collected. The center is just going to be an estimate for this. I'm not going to have you count to necessarily the middle, but you should have a pretty good idea where the middle is. And the spread is just the lowest value to the highest value. And we'll do an example of that, of the SOX, in just a minute. Now let's take a look at a couple of examples. An example of a stem plot using the number of states you've visited and determining the SOX, and then make a dot plot with the age of one of your grandparents and determining the SOX. Now we're going to use the sample data from the other sheet in order to do this. So let's go ahead and start with the stem plot. The stem plot that we're going to do is called an ordered stem plot, which means we have to put all of the data in the correct order. So the first thing you should start off by doing is rewriting the data in order from smallest to largest. Once you have that, you have to identify what the smallest value is and the largest value is so you can determine your stem. Because we have single digit and 2-digit numbers here, my stems are always going to be 1 digit, the first digit. My leaves are always going to be the last digit. Whenever you do the leaf, we only want the last digit in there for the leaf. The stem can be more than 1 digit, but the leaf should only be 1 digit. Because we have single digit numbers, we're going to start with a 0, and then we have the teens, the 20s, the 30s, and the 40s for the rest of our stems. So you're going to take the numbers here and line them up in order from smallest to largest, making sure that they're evenly spread out. And that's why it's nice to use graph paper when you're doing stem and leaves, or you should be careful that when you write them, you line them up in columns so that they're one right above the other one. With any display that we do, you should always have a title, in this case, number of states visited, and you should also have a key whenever you do a stem plot. In this case, 4-8 means 48. So let's go ahead and take a look at our SOX then. This data would be skewed right. If we look at it like this, it might be hard to tell, but if we turn the paper like this, we can see that if this was like a bar graph, the data would start here and it would tail off towards the right. Whenever it tails off towards the right, that means the data is skewed right. The next thing we're going to look at is an outlier. Now, in this case, 48 might be considered an outlier because it's kind of far away from 34. But there's no gaps in our stem plot, so I don't know that it's really an outlier. If this was a test question, I would probably accept either none or 48 as a correct answer. Then we have the center. The center is just the piece of data that's in the middle. Now you can just estimate this by kind of looking at how many there are, or you can count the pieces of data on one side and count the pieces of data on the other side and make sure you're in the middle. The spread is just going to be the number, the smallest number to the biggest one. So we'll just say 2 to 48. Now let's take a look at a dot plot. For my dot plot, I'm going to do the same thing. I'm going to start off by listing all of my data. Now, it doesn't have to be in order when you're doing a dot plot. The only thing that you need to do is you need to find the smallest value and the largest value so you can set up your number line. In this case, my smallest value was 60 and my largest value was 94. So I went from 60 to 95. Making sure that all my data is evenly spread. In this case, each one of my lines represents 1 year of age. Notice in this I have the number line labeled with age and number of years. I have the display labeled with grandparents' age. Then we went through and you just put a dot above each one. So when I start with my first piece of data, 70, all I have to do is come here and put a dot above the 70. Then with 82, I find 82 and put a dot there. Making sure that as you're going up, the dots are evenly spaced. In this case, each dot is just 1/2 of a unit on the graph paper. Once you have all of the pieces of data plotted out, then you can take a look at your socks. Now in this case, I'm going to call this symmetric. If I look at the graph, it starts here, it goes up, it comes back down to here. Now I do have this one out here that's kind of an outlier, so if I don't include that, it's very symmetric. If I do include that, you might say that it would be skewed right. But I went with symmetric for this, because when there is an outlier, you generally don't include that in your data for the shape. Now in this case, the outlier is 95. That is quite a distance away from the rest of the data. The center is about 74. So if I counted the pieces of data this direction and counted the number of pieces of data this direction, the middle would be 74. But again, if you said 73 or 75, that would all be considered okay. Then we have the spread. The spread goes from 60 to 94. And we just write it right like that. The last thing that I'm going to want to do is take a look at some different stems. So if you had data that goes from 7 to 52, what would your stems be? Well, we would have to have a single digit, so the first stem would be 0, and then we'd have to go up to the 50s, so then I would go up to 5. In this case, we have 2-digit and 3-digit numbers, so I would start with 8, which would be my smallest 2-digit number, and then I would have to go up to 12 for my stems. And then the last one, if I went from 1.2 to 4.0, again, I would start with my smallest, which would just be a 1, and then I would go up to a 4.